I am going to teach you how to identify whether a graph and scenario is linear, exponential, or neither. First, we're going to start with this graph. This graph is very easy to identify as it is a linear graph because every linear graph has a straight line. Whether that straight line be diagonal, horizontal, I don't believe vertical works, other diagonal, some weird angle, I don't know, almost perfectly upwards. If it's a straight line, it's linear. Okay. Now for the next graph, this one's also easy to identify, as exponential graphs always follow a curve, where it is very horizontal at one end, to then become super vertical on the other end. It can be this. It could be this way, this way, this way, this way, or some other random way. And here we have our next graph. This graph looks weird. That's because it is weird. It is not exponential or linear. And that's how you do it. It is neither exponential or linear, and that's how you identify whether a graph is exponential, linear, or neither. This graph, it is in a straight line, and it is in a curve. So it's not either of them. Here, we have a word problem. Jared is growing a colony of bacteria. He started out with only one bacteria, but the bacteria multiplies itself into 2 every 30 minutes. Every time the bacteria multiplies, its copies also multiply. And that's all the information you need to know. All this, useless. Ignore it. But we should be able to circle the important information. He started out with only 1. So let's get a 1. The bacteria multiplies up into 2. Let's add a 2. Every 30 minutes. I guess that's just a time interval. Every time the bacteria multiplies, its copies also multiply. So not only the bacteria itself, its copies. Which means this is exponential because, well, if you have 2 bacteria, it's going to multiply into 4 if both of them multiply into 2. Which makes this exponential. And here we have our next problem. There's an oak sapling that grows in Jared's backyard. Jared measures how much the sapling grows each day. It always grows by 2 inches every single day. Make a graph and ignore that. Alright. So we shall circle the important information. It grows by 2 inches every single day. Which means 2x. This would be the answer to the equation. And now I forgot to make a non-linear or non-exponential equation. But it's very hard to make one of those. So imagine little Jimmy. Look at him. He's happy. Little Jimmy has a bag of marbles. See that? That's a bag of marbles. And every day, every single day, he takes some marbles out. See? Every single day, he takes a few marbles out. Well, not just a few, a handful. Jimmy takes out a handful of marbles every day, and he has no control over how many he takes out. So for one day, he might take out 1 marble, while on another day, takes out 9 marbles. And he does not control them. He only gives his marbles to his dad, because little Jimmy loves his dad and wants to give him marbles. So little Jimmy has no control over how many marbles he gives to his dad on a specific date, which makes this equation, makes this graph and scenario non-linear because there's nothing specific and everything is random.